Chapter 6 Applications of Newton's Laws. Problem-solving strategies. We emphasize the specific strategies that are useful in applying Newton's laws of motion. Once you identify the physical principles involved in the problem and determine that they include Newton's laws of motion, you can apply these steps to find the solution. Number 1. Identify the physical principles involved by listing the givens and the quantities to be calculated. Number 2. Sketch the situation using arrows to represent all forces. Number 3. Determine the system of interest. The result is a free body diagram that is essential to solving the problem. Number 4. Apply Newton's laws to solve the problem. Number 5. Check the solution to see whether it is reasonable. Friction. Friction is a force that opposes relative motion between systems in contact. If two systems are in contact and stationary relative to one another, then the friction between them is called static friction. If two systems are in contact and moving relative to one another, then the friction between them is called kinetic friction. The magnitude of the static friction, Fs, is less than or equal to μsn, where μs is the coefficient of static friction and n is the magnitude of the normal force. The magnitude of kinetic friction, Fk, equals μkn, where μk is the coefficient of kinetic friction. Friction and the inclined plane. One situation where friction plays an obvious role is that of an object on a slope. It might be a crate being pushed up a ramp to a loading dock or a skateboarder coasting down a mountain, but the basic physics is the same. We usually generalize the sloping surface and call it an inclined plane, but then pretend that the surface is flat. Atomic scale explanations of friction. Great strides have been made in the atomic scale explanation of friction during the past several decades. The figure here illustrates one macroscopic characteristic of friction that is explained by macroscopic research. The friction is proportional to the normal force, but not to the amount of area in contact, a somewhat counterintuitive notion. When two rough surfaces are in contact, the actual contact area is a tiny fraction of a total area because only high spots touch. When a greater normal force is exerted, the actual contact area increases, and we find that the friction is proportional to this area. Centripetal force. Any net force causing uniform circular motion is called a centripetal force. The direction of a centripetal force is toward the center of curvature, the same as the direction of centripetal acceleration. The magnitude of centripetal force, Fc, is mac. We get two expressions for the centripetal force Fc in terms of mass, velocity, angular velocity, and radius of curvature. Banked curve is a curve in a road that is sloping in a manner that helps a vehicle negotiate the curve. Ideal banking, the sloping of a curve in a road, where the angle of the slope allows the vehicle to negotiate the curve at a certain speed without the aid of friction between the tires and the road. The next external force on the vehicle equals the horizontal centripetal force in the absence of friction. The non-inertial frame of reference is the accelerated frame of reference. Inertial force is a force that has no physical origin. Like friction, the drag force always opposes the motion of an object. Unlike simple friction, the drag force is proportional to some function of the velocity of the object in that fluid. This functionality is complicated and depends upon the shape of the object, its size, its velocity, and the fluid it is in. For most large objects, such as cyclists, cars, and baseballs not moving too slowly, the magnitude of the drag force, Fd, is proportional to the square of the speed of the object. Terminal velocity. Constant velocity achieved by a falling object, which occurs when the weight of the object is balanced by the upward drag force.